Hey everyone, welcome back to the channel. कैसे आप लोग? So friends, in this particular video we'll be solving this question, that is count good nodes in a binary tree. So friends, given a binary tree root, this is the root, that is 3. A node x in the tree is named good if in the path from root to x, like from root to this particular node, let's suppose it is x, there are no nodes with the value greater than x. So over here, as we can see in this particular track, it is 3, the root is 3, and the path from 3 to 4, there is no other node which is greater than 4. So it is a good node. And friends, the root will always be a good node because there are no previous nodes to the root. And we can see, like we can follow this path 3, 4 and 1. Let's suppose this is x node. So this is not a good node because we have 4 which is greater than it. And if we cover this particular track, then in this track we have 5. First we have 3 as a good node, then when we reach 4, then 4 is a good node, then we reach 5, then 5 is also a good node, because none of the nodes which are like previous to this node are greater than it. So cool. So 5 is also our good node, and over here 3 is also our good node. So friends, hence the total number of good nodes that we get as output is 4. So think, what could be the approach to find the number of good nodes? So friends, the approach that we can follow could be pre-order traversal. So what we can do is we can take one counter variable that will keep the count of the good nodes, and we can take a max, and we can always, while we are going down the path, we can always check the max value. If this is greater than the previous max, then we can update our current max, and then we can also say that yes, it is the good node, and we can do this by using pre-order traversal. So friends, without further delay, let's understand the same using dry run. Okay, we will do the dry run first. We will understand the recursion call stack first, then we will be doing the coding. So friends, let's try to understand this question, that is count good nodes in a binary tree. So friends, this is a binary tree that is given to us with the root as 3. And we have to find the good nodes in a binary tree. And friends, so the approach that we will be taking will be pre-order traversal. We will be doing pre-order traversal, and pre-order traversal is root, then left, and then right. So this is our pre-order traversal. So what we are going to do is, first we are going to perform the operation on the node, root node, and then we are going to go for its left and right child node. So friends, let's try to understand the dry run first. Basically the recursion call stack first, then we'll be doing the coding. So friends, let's first take two variables. One will be the counter variable, that is 0 for counting the good nodes, and apart from counter variable we'll be taking one max, and let's suppose its value is minus infinity, or you can give it the lowest value as possible. So in JavaScript, what we can do, we can give it number dot mean safe integer, mean integer. Okay, now let's do the function call. So friends, first 3 is passed to the function, and now the function call will begin. So first it will check if 3 is null or not. So 3 is not null, then what it will be doing is it will be comparing 3, basically this node's value, with max. If it is greater or equal to max, then it will be updating the max as this particular value. So over here, yes, R3 is greater than this particular max value. So our max will become 3 over here, and our counter will also increase. Now friends, what will happen? This particular 3, after doing this operation, it will make a call for its left node, that will be 1. So it will be making a call for 1. After making a call for 1, it will again check whether it's null or not. So it is not null, then it will check if it is greater than this particular maximum, yes or not. So it is not greater than. So what will happen over here? It will not go into that if condition, but it will make a call for its left node, that is 3. Cool. So friends, when it has made this call for its left node, it will again go into the if condition. It will check if it is greater than or equal to the current max. Yes, it is equal to the current max. So what will happen for this particular 3? Again, the max will be like 3 only, but the counter variable will increase to 2. Cool. And now what will happen, it will check for its left and right. Like it will again go for its left call and right call. So friends, but over here for this particular tree, the left is also null and its right is also null. So it will simply return back to it. Over here, as we can see, it's left and right is null. So we will simply return back to the tree. So its left and right call are finished and the call will return to the parent caller, and the parent caller has like finished the call for left subtree. Now it will check for the right, which is nothing but uh, if we look over here, it is nothing but a null. So it will also return back to this particular call. Now it will again return back to parent, and now parent has done the left tracking. Now it will go for the right, and in right we have 4. So friends, this parent now will be going to call for this particular 4, and now 4 also it will try to check for it, like it will check that if it is greater than the max or not. And friends, the max over here is 3, and currently the counter over here is 2. So the max, it is greater than max, then max will be updated to 4 and counter will be updated to 3. Cool. Now what will happen, now it will again make a call for its left, root left right. So left, that is 1. So over here the call will be made for 1. So again the same criteria will be happening for 1 as it happened over here. It will check for its left, but its left is null and its right is also null. So what will happen, we will get null over here and we will get null over here. And as per the code, if we get the null, if the node is not present, then we simply have to return. So the call will be returned back to the parent caller, and after 1 it will be returned back to 4, and now 4 will be calling for 5. Now 4 is calling for 5. Now friends, what will happen over here, once again it will check what was the max previously, it was 4. So now the max will be, as it is greater than, as it lies in that condition greater than or equal to, so it is greater than max, so max will be updated to 5 and counter will be updated to 4. Cool. And friends, it will again go for its left and right, but as we know, its left is also null and its right is also null. So this will also return the call back to parent caller, and finally the answer that we will get is number of good nodes. So this is the counter that is storing the number of good nodes. So the answer will be that number of good nodes is 4. Cool. Because this 3, 2, and this 4 and 5. So the good nodes that we got are, if we have to write it, so the good nodes were 3. Basically we had 3 2 times, then 4 and then 5. So these were the number of good nodes. So friends, this is the recursion call stack. I hope this is clear to you all. Now let's begin coding. Welcome back friends. I hope the recursion call stack that I just showed to you was clear to you all. Now let's quickly do the same in coding. So friends, this is the function that is provided to us, good nodes. What we can do now, let's first take the counter variable as I have shown you, and let's also you can take the max also, like I have shown you, number dot mean safe integer. So friends, it is the minimum value, like mean safe integer in JavaScript. For like Java, C, C++, there could be something else, so you can use that one. Now what we can do, we can make another function of count good nodes, and let pass it the root and the max value. Now friends, the first thing that we are going to do is check if root is null or not. If root is null, then simply return. And now you can check if this particular root, you can actually say it as node, And now we can check if node.val is greater than or equal to the max, previous max that we were getting. So what we can do, we can simply update max with node.val, and we can do is counter plus plus. And friends, now what we can do, we have first traversed the route. Now we have to go to the left. Now how we can go to the left? We simply need to call this recursively with node dot left comma the max for that particular path, and now over here node dot right with max. And friends, this entire code will compute the number of good nodes, and finally we just simply need to return that number of good nodes. Let's see if it runs successfully. So friends, we got some error. Actually expected 4, but we got 0. Okay, cool. So let's see why. So friends, we got 0 because we did a silly mistake over here. Actually we didn't call our function but obvious, so we need to call the function also. So simply pass this max, current max, and now let's check if it runs or not. Cool. So friends, as we can see, our test cases are passed successfully. Now let's submit it. So friends, the solution was accepted, and I hope the question and its solution along with the dry run and this coding that I tried to explain you was clear to you all. And friends, this is it for this particular video, and if you have not understood any part of it, then you can directly ask me on the Instagram or in the comment section. So friends, this is it for this particular video. We'll be meeting in the next video. If you like the content, then don't forget to like, share and subscribe to the channel. Thank you for watching. Thank you.